my mic was muted. We're doing great. Okay, that's minus aura. Yeah. So this is gonna be maybe a little bit of a longer stream. Um, yeah, hopefully I can get a little bit more of the kaleidoscope stuff done. I am in quite a bit of a mood to work on it. Um, today's day 7, so I guess it'll have been a week after today, which is pretty huge actually. It's already hard enough to get me to do anything for a week straight. So, yeah. In terms of what I'm gonna work on today, there's the LLVM codegen chapter of kaleidoscope tutorial, so I'll try and get that. Um, and then I might look at the next chapter depending on how time looks. Hopefully, I'm not like that abhorrently slow. And then when the LeetCode daily comes out, I'll do that, and then maybe at some point I'll throw in a little bit of personal compiler work. So yeah, should be a good time. Yep. Oh yeah, I restarted my laptop. Unlucky. Okay, so where were we last time? Yeah, I guess I should demo what I had from last time. So we had a little bit of cmake work done. Um, yeah, so all of the basic cmakelist stuff is done, as well as makefile. The parser is fully done. So now if we put in a basic kaleidoscope program, it parses the function properly. Yippee. Okay. Oh, wait, I see. That was not valid program. There we go. All right, first try. Yeah. So the parser works. I did a little bit of hand testing last time, and it's quite functional. Real quick, before I do more work, I should probably figure out dark mode on LLVM docs, because this is quite annoying me. So we're gonna look up Sphinx dark theme. Is there a way to do this? Settings, language appearance, website appearance, dark. Eh? Yeah, so it is dark. Yeah, this is not quite helpful. There has to be a better way to do this, surely. Yeah, okay, so it looks like I'd have to just build the docs from scratch, which is admittedly not something I particularly want to do right now, so we're just gonna skip that for now. Um, yeah, so let's start with codegen to LLVM IR. This should be pretty fun. So last time we have an AST, now we get to turn that into LLVM's internal code. This is quite interesting to me as well. Code here requires VM version. Should probably look at that. Okay, yeah. So I do have it installed. Okay. So we need to define virtual codegen methods. Yeah. So this is in the AST. And the interesting thing is that usually this is done with the visitor, but we're being a little bit lazy here, so yeah. The codegen method says to emit IR for that AST node. Says to emit IR for that AST node along with all the things it depends on. Okay, sure. That makes sufficient sense to me at least. Yeah. Okay. So then value codegen. And then value we don't know exists yet. So I'm actually gonna make another. I'm gonna open this again in a separate place so I can look at the headers that it's importing. LLVM. So I'd go here. LLVM. Lord knows which one it belongs in. Surely IR builder. Let's start looking through the docs actually. This is LVM 21. 21? 20. I think. Docs. LVM docs. VM. So what are we looking for again? We're looking for value. Oh, that's not helpful. Let's just use Google. Oh, there we go. Do we import value at all? No? Okay. That doesn't really help me. Let's just do this for now. What happens if I... Actually not. think I do need that for now at least. I'll fix imports later. Value represents SSA value. So is there an SSA header? Okay, sure. The most distinct aspect of SSA values is that their value is computed and as the related instruction executes, and it does not get a new value until and if the instruction re-executes. So what that's saying is basically they can't variables SSA values can't be reassigned. Hey Janine, how's it going? So there's no way to change an SSA value. Grok. Great. I said probably be good to read this at least. Or at least like skim through it again. It's been a second since I've looked really closely at SSA form. Thanks, Janine. I appreciate it. For each variable, it's 10 once. For some reason, I didn't expect GCC to use it. I don't know why. So split into versions. New variables are typically indicated by the original name with a subscript. Additional statements may also need to be introduced at the join point. Sure. Ha, diffuse trains. Nice. Preserve SSA. Oh, that's really cool, actually. What is CPS? Interesting. Okay. Let me just take a look at this. I can't read this. Takes a continuation. I'm not really getting what this means. This is quite confusing to me. Oh wait, continuation. Wait. Okay, I see. Okay, so yeah, that roughly makes sense. Ooh, fee function. It's quite interesting actually. I might take a second to just like read up on this. This Citron paper is quite famous if I remember correctly. Unless I'm thinking of a different Citron paper. Replace identity assignments with fee functions. Just name. Optimization. Phony function. Interesting. There we go. This is the paper I'm thinking of. Okay. Yeah, so this is a good example of how SSA form works. So given this piece of code, we assign y to 1, we reassign it to 2, and then we assign x to y. And at a glance, it's pretty obvious that we don't need this line of code here, but or at least assuming y is the only value that's used, or I guess x is the only value that we care about at the end, because we can just follow this backwards. But it's a little bit annoying to I guess figure out algorithmically, since you need to figure out which variables are alive at which instance. I guess like not alive, but the term is like reaching. We need to figure out reaching definitions, which pretty much is like redefining variables, to my understanding. So with SSA form, on the other hand, each of these are treated as an individual value. So it's pretty trivially easy to tell that the only thing x1 now depends on is y2, and y2 is assigned as 2, and this y1 is never used. And there's a whole lot of optimizations that depend on this. This conversion stuff is interesting, and I do need to learn about it eventually, but this is a future me problem for when I go back to working on my personal compiler. Yeah. There's a lot of stuff here. A whole lot of stuff. Anyway. Yeah. Grok. I still can't get over Grok being here. That's pretty funny. For better or for worse. Instead of adding virtual methods, let me make the brightness more readable for myself. Note that instead of adding virtual methods to AST, we could use a visitor, like any other good software engineer. Yeah, fair enough. Each AST class. So we got a lot of AST to copy codegen for. Let's paste it again. ZZ, that's how we center. Yeah, we're slowly learning as well. This is different. Okay. Let's do cross check. Where is the AST? AST. Codegen override. Binary export has it. Call has it. What else has it? Prototype has codegen. And function also has codegen. Okay. Does this have LLVM namespace? Is that what's happening? Yeah, okay. I probably should do that, but whatever. So this goes here. There we go. I think that's all of them in the header at least. Second thing we want is log error. So codegen is what we call to literally generate code. I guess that makes sense. And then these LVM values? Just making sure. Function, and then function. Interesting. Okay. That's also from value. Interesting. 17. Also, let me know if the music is too quiet or too loud. I'm gonna try it out again because I feel like it helps fill a little bit of the dead space from when I'm just staring at docs, which will admittedly be a large portion of my streaming experience because I am quite literally learning everything on the fly, so it's kind of inevitable. Log error. We want log error like we did for the parser. That makes sense. The context builder. So how do we want to represent this? I guess we can just stick them in here as static variables, honestly. Wow, all of these come from the header. That's neat. There's got to be a better place to pull these headers from. Constants.h. Oh wait. Oh wait, what? Namespace LLVM. Using. Right? Is this? Yeah, okay. That makes sense. But I need to import it from somewhere anyway, so I guess I may as well just do it like this. This is not a thing. Type H. Value. Yeah, we'll just do value for now. Call it a day. We don't need to overcomplicate it. I say as I deviate from the tutorial substantially. Let's make another unique footer to or IR builder. This is LLVM builder. Does this work? Apparently it does. Okay, you know what? We'll do it like this for now. Our builder will be largely sufficient. By largely, I mean currently sufficient. Unique footer module. Basic block. Yeah, okay, that'll do. Interesting the linter isn't mad at this yet, but sure. Then we actually need to import something again. So this asks from string to value pointers. Yeah, that's alphabetical. That's good. And then make value log error b, and this takes a C string or C style string. Log error. Okay, sure. Builder objects. So context owns core LLVM data structures. Builder. So it makes it easy to generate instructions. I don't really get that. Our builder class template keep track of current place insert instructions and has methods to create instructions. Okay. Alright, so it's like a utility. I guess that is what a builder is. The module is an LLVM construct, contains functions and global variables. In many ways, it's the top level structure that the LLVM IR uses to contain code. It will own the memory for all of the IR that we generate. Okay, I see. It returns a raw value. Okay. And then name values keeps track of which values are defined in the current scope and what their representation is. So it's a symbol table. Okay. Neat. Things that can be referenced are function parameters, so they will be in this map. And then what do we do with log error v? Where does log error come from? Does that come from the lexer? No, not the lexer, the parser. Yes, it does. Okay. Yeah, we should probably move this over then. Actually, this is a little bit messy, actually. Feels simultaneously. This just feels like bad design, which is, I guess, kind of the point. Because it's just a tutorial. There has to be a better place to put this, though. Hmm. Hmm. Just read through this a little bit. I see. Okay. Okay, so we can just re-implement this, honestly. Yeah, we'll do a little bit of. We'll do a little bit of code duplicity. Oh wait, this is a header. I see. Yeah, let's actually get this out of here. Let's put this in the AST CPP file. Oh, I'm getting lost. Yeah, here we go. This goes here. Yeah, this looks reasonable to me. Okay. Alright, so now we can start generating code properly. This assumes that builder has been set up to generate code into something. Okay. Sure. Generating code for expression nodes is very straightforward. Less than 45 lines of commented code for all 4 expression nodes. That's actually really straightforward compared to this the giant parser mess that we had. Where the header alone is 33. And this whole thing is 200. That's pretty cool, I guess. So let's go to. We should go to here. Let's work through these one by one. So codegen here and x per AST. Actually, that's the virtual one. That's the one we shouldn't implement, I think. We need these for all of these, it looks like. And then put one here. Yeah. Let's do all the replacement here. Am I missing something? Anyway, let's just get this. Let's start working on this. Constant. Okay, so that's the floating point constant. Get we passed in the context, and then AP float. Okay. Does this go like this? There we go. Okay, I see. Let's define a macro to do this. Okay. And this is a very silly macro. So my laptop is burning up. Alright, so what does this do? Okay, so floating points are constant FP. I guess that makes sense. AP float is arbitrary precision. That makes sense. Okay, that makes sense. Yeah. Uses the get unique together and shared. Oh, I guess that makes sense. Yeah. So constants are like singletoned. Sure. Singleton? You get what I mean. Next one is variable expr AST codegen. So, okay. So if it doesn't exist, then we yeah, if it doesn't exist, then we log that it doesn't exist, and then we return the thing. We assume that it's already been emitted somewhere and its value is available. The only values that can be in name value map are function arguments. Oh, okay. 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 Reference variables. Well, yeah. Okay. I guess this makes sense because our kaleidoscope language literally does not have variables. So, or as in like the only variables that exist are provided through function arguments. So yeah, I guess that seems sensible. Um, Loop induction variables. Uh, that's not helpful. Oh, okay, I see. That makes sense. I guess that one will be a little bit easier when we add like local variables and stuff. Binary operators. So we recursively make code for the left-hand side, then the right-hand side, then we compute the result. Okay. Okay, yeah, that makes sense. Okay. And then the builder is really helpful here because it deals with the instruction insertion just manually. The name is just a hint. So it emits multiple add temps. Oh, okay. That's nice. Okay, that makes sense. String by strict rules. Left and right operands must have the same type. Result type of the add must match the operand types. Okay. That seems pretty fair enough. And then we have to cast the comparison value. Then we need unsigned. Okay. Yeah, that makes sense. That signedness makes sense to me. Yeah, okay. Let's have fun with this now. So we call codegen on left. So we codegen these. If L or R are null pointers, then we return null pointer. Then we switch block on the operator so that it can either be addition, in which case we builder create f add left, right, and then add temp. Subtemp. And this one's multiply. This one's multemp. is sub. This one is fmol. And then last one. So comparison. This one is oh, I see. So this comparison is different because we actually have to deal with that little casting thing that I mentioned earlier. So we replace left with create compare unsigned less than. This word is pretty funny. I like comp temp. So then we create unsigned integer to floating point. So we do left and type get double tie. And what do we pass in here? Context pointer. And then we pass in bool temp. Wow. And then the default case, we log error. Okay, that makes sense. Yeah, this block of code seems pretty sane, actually, to be honest. I feel like it was not that hard to figure out. Okay. Now function calls. How close are we to done with this? Oh, actually, that's not that bad. Wow. It's quite quick. It's a function name lookup. And we can use the symbol table to resolve the function names. And then we code gen each of the arguments and then create a call instruction. Okay, yeah. So we make sure the thing we're calling exists. And we create the things that we're passing into the call, and then we create the call. That makes sense. That makes perfect sense to me. So let's go here. So you make the callee module get function callee. Member access into incomplete module. What else do we need to add again? We need to add module. Yeah, okay. That's what we're missing. So if it doesn't exist, then we log error. That there's an unknown function that we referenced. Okay. And then we check for arity. Arg size. And then we log error. Incorrect number of args passed. Make a value pointer vector. Args v. Make sure it's LVM. Unsigned? Okay. What are we doing? Let's do auto 9. Ah, I see. Can we just do that? Okay, yeah, we can do that. Args v dot push back. Arg. I don't understand why this is there, but I'll read up on that in a second. So then builder creates a call with the call function, args, and then call temp. Yeah, I guess. Sure. There's other easy instructions, it looks like. I should probably read through this at some point. Oh, this is quite long. On second thought, maybe I don't read through it immediately. I might take a look at this in my free time. Yeah. Okay. I'm gonna head to the bathroom real quick. When I get back, I will handle function code generation. So literally generating code for functions and I guess prototypes. And then just updating the driver so that we can actually see all of the incredibly high quality code that's being generated here. So yeah, I'll be right back. Okay, I'm back. Oh, hello. Yeah, that was in fact one of the bathroom breaks of all time. Codegen, codegen. Um, yeah. What do we do here? So let's handle details. Showing his code less beautiful than expression codegen. Okay, sure. Prototypes are used for function bodies and external function declarations. Packs a lot of power into a few lines. The way this is written, I feel like I should write it out first and then figure out what it actually says. So let's go down here. Yeah, here. And then let's see, where do we have this? We can just steal these from here. This is prototype, AST, codegen. What did I do? And this one's function, AST. So let's see. So make a vector of type pointers. Doubles? Oh, doubles, like the literal type. Okay. So LLVM type, get double tie, and then we pass in the context. What else do we need here? Where am I? 9 lines up. So then we need the function type and the function. Oh, this is gonna be a mess. LLVM type, get double tie. We have doubles, false. I don't really know what's happening here. Oh yeah, this is quite substantial. Yeah, how do we even format this properly? Yeah, there's no good way to format this. Should probably make some of this naming a little bit more consistent. Let's fix the case on some of these. This one also fixed case. Yeah, consistency is quite important just for my sanity. Yeah. I think builder, or I guess all these static variables I think is fair. I think there's a reason to it at least, so I think that's fine. Same with that one. Yeah, this is just a gross giga long train car, but it is what it is. And then we have to do it again. Ha 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 ha. Maybe we can just tack this on and call it a day. Yeah. And then LVM function. Are the rest of these fine case-wise? Yeah, looks good to me. Yeah, where were we? LVM function, external linkage. Ugh. Name module get. Maybe I should just do this. Yeah, this seems a little bit more sane actually, which is really funny because it's, well, not at all more sane, as a matter of fact. It's like, this is just doomed. This one's just doomed. This one's like truly just doomed. What am I doing? Yeah. So this function returns a function star instead of a value star. This prototype really talks about the external interface for a function, not the value computed. Makes sense to return the LLVM function it corresponds to in codegen. That makes sense. That seems reasonable enough. Call the function type get creates the function type that should be used for a given prototype. So we are on here. all function arguments are of type double. First creates a vector of n LVM double types. And uses the get method to create a function type that takes that many and returns a double. Okay, yeah. So yeah, that makes sense. And false indicates it's not variadic. Types in LVM are unique, just like constants are, so you don't new a type, you get it. Okay. That makes sense. And this line creates the actual function. Responding to this prototype, which indicates the type and codegen name to use, and which module to insert it into. Okay. So the type is the function type. The linkage is externalable. Name is the name, and then the module is the current module. Okay, that makes enough sense to me. Yeah. Let me set the name of the arguments, which isn't necessary, but makes it more readable. Okay. Interesting. What else do we do here? Args. Oh wait, I understand why it does it like this now, because we want to access this once. F args equal auto f args equals args. Oh wait, no, I actually can't do it like this. I understand why it does it like this now. We set name to args at the index, and then we increment it after. That's pretty neat. So my laptop is feeling a little bit toasty. It's really enjoying this. We return F. So that should be good for that. So a function prototype, and it has no body. That's kind of based. So this is how LLVM IR represents function declarations. And this is as far as we need to go for extern statements. Okay. And then we need to codegen and add the body for, I guess, functions that aren't extern, so internal? I don't know. Ew, yuck. What is happening here? This code looks a little bit silly, but I guess it makes sense. Yeah, okay. So you start by searching the module symbol table. In case it's already been created with an extern statement. Okay, yeah. So extern can also be empty, which is why it's written in this really funky way. Yeah, okay. Module, get function, proto. Get name. Does this look good? This looks good. Oh, this is a pointer. What else? Next, if the function doesn't exist, we make it exist if it doesn't exist. If it still doesn't exist, then we return a null pointer because then something went wrong. If it's not empty, then we return. We cast the null pointer to. Okay, sure. Yeah, function cannot be redefined. Okay. LLVM function. Okay, so we're here now. Basic blocks. My favorite. Yeah, we love basic blocks out here. Should probably read up on these formally. So let me pull up a diagram that explains this a little bit more clearly. Yeah, so in this example code snippet, let me make it bigger. Yeah, I guess this will do. So each of these, so I guess if you take a program, it has a lot of different control flows it could possibly take, which is represented by these arrows. So like this is where everyone's favorite like for loops, while loops, if statements. They all create code flow in a way that you can't really like just read the code top to bottom. So the first idea people have is to simply turn the program into a graph by by just having each instruction point to the next instruction. But the problem with that is that that's a little bit complex, and it makes analysis really slow. So the way we can simplify this is any sequential set of instructions that will always run in that order, we can group into what's called a basic block. And then we can simplify the graph a lot without losing any information. So that's what's happening here. So notice how at the if condition it branches off into the true and the false branch, or I guess just the true branch, and then the false skips to the after condition, and then the while loop here. So the yeah, so this is the loop itself. So if this condition is true, it goes into here, and then it goes back up to this basic block, and then it checks again, or it does that again, and then checks again, and then once the condition is false, then we move out to here, and then program flow continues. So the point is, basic blocks are sequential instructions, and that's important here because our functions are pretty simple, I think, in the subset of Kaleidoscope we have. All we have is just if statements, it looks like, but I don't think we cover that yet. Yeah, we definitely don't have if statements yet. We just have simple arithmetic for the most part. Yeah. So anyways, going from that forward, let me just move this to the side. So we can very trivially just create a basic block. Regardless, we need to create one basic block just as like the entry point. Yeah, this is where everything starts. Yeah. So, and all of this sets up the builder, it looks like. Yeah, okay, cool. LLVM basic block db is basic block create. We pass in the context and then entry. And then the function. Oh. LLVM. Okay. And then we set the insert point to that basic block. And then we add the function arguments to the named values map. So we clear and then we add them. Okay. Nade shot. So for each argument in args, we don't even need brackets here. Name. Okay. Yeah. Yeah, and we don't have control flow yet, so this is a little bit silly, but so it goes. So now we add the function arguments. Yeah, and that's what this does. Verify function. That's a function. Okay. Now if value, where is value? Oh, LLVM value ret. So this is the return value of the function. So if this is equal to, where does body come from? Body codegen. So then we so if we have a value, then we create a return value ret val. Verify. And then LLVM has a verify function. LLVM verifier. Okay. And then we need to import this. Verifier.h. Right? Okay, yeah. Oh. What? Lowercase v. And then here we return the function. Now happens, this emits code to compute the expression into the entry block and returns the value computed. And we create, return, and verify it. And return it. And then otherwise we had there was an error somewhere in the body, so then we removed the function. Erase from parent is crazy. And return null pointer. Okay, there was a bug to fix apparently. But yeah. Else when merely deleting the function we produced. So let's use a redefine a function. It's incorrectly typed. Okay. Anyways, we're gonna take a break from this to do a little bit of LeetCode. Yeah, let's move this here. Yeah, there's always time for LeetCode. And the daily's up. New 21 game. I like how they aren't allowed to say blackjack, so they call it 21 game. Um, 21 card game. Is this actually a thing? Okay, it is just blackjack. Okay. Okay, anyway. That's pretty good, to be honest, I can't lie. "21 game. Randomly from that range. Okay. This feels very backtracky to me. Let's see what the topics here are. DP? Oh, actually, that makes sense. Sliding window? What the? Okay. So the brute force way to approach this problem would be to draw literally every single, I guess, calculate each possible end result. Okay. Yeah, this problem seems a little bit annoying. I'm down for it. Let's have some fun. Okay, so we can iterate across n. The 2D solution seems a little bit simple to me, or at least reasonable to me. DP across so K is the maximum points. Wait, no. Wait, what? Oh, K is like the ceiling for points. Range 1 to max points. There should be a way to do this 1D. This feels kind of knapsacky. Something about reverse iterating. Okay. P equals so the most number of points can be So we need a vector of double DP. And this is size I think K plus N is the maximum, right? Or I guess 2K or no. Because the maximum possible is if they are 1 below k, and then they pull the biggest possible number. No, so it'd be k plus max points. K plus max points. And then probability here. Let's start with 0 for now. That seems sane enough. So in DP, the probability of getting okay. How do I want to do this? So we need some for loop here, and then for each iteration, we don't know how. I don't know how many iterations yet, but int j equals, and then this is an inclusive range, so max points. J is greater than 1, greater than 0, j minus minus. For int k equals j 1 is, there has to be a more sane way of doing this. Ah, I see. So an I would have to, so the maximum possible number of hands would have to be because the minimum possible number of points per draw is 1. K points is the maximum number of K is the ceiling for how many points. Yeah, so 0, I is less than k, I plus plus. So that's the number of cycles we do. At each cycle, we might want to do a default cycle at least. And k can be 0. Okay, cool. That's very helpful. So if k is 0, then 0, then return 1, I think. That sounds correct to me. Anyways, what do we do here? What do we do here? I mean, the brainless way to do this would just be to like literally create. This is just like making a histogram, but like algorithmically, it looks like. I don't think there's a better way to do this. Is there a better way to do this? Okay, let me think about this. Let's say n equals n is, we don't worry about n for now. The final calculation is pretty easy. So let's say k is equal to 5, max points equals 10. Let's do n equals 5. I don't know. Let's just do this for now. So we can have up to, so we have to have at minimum 5 points, I think, right? Stops when they get k or more. So 5 is the literal minimum here. And then 6. What is the ceiling here? The ceiling here is 4 plus 10, so 14. Okay. So 5, there is one way to make this. Or, yeah. 6, there are... Oh, this is a little bit annoying. Wait, no, there's not one way to make 5. So there is... Oh, this is quite annoying, actually. There's 1, 1, 1, 1, 1. Let's start with a smaller k, actually. 3. And then let's set max points to 5 for simplicity. So 7 is the max. So we have 3. We have 2, 1. We have 1 1 1. Let's get rid of the comma. 2 1 1 1 1. And then 1 2. That's the 4 possible ways to get that. And 4, we have so we have just straight 4. And we have okay, I see. We can do this bottom up, it looks like. Actually, this makes sense. Yeah, okay. Then we have, so this one has, so this one just has, oh, these 3 have a way to make it just by default. And then we have the number of ways to make 3. So then here we have 1 3. We have 3 1. And we have 1 1 1 1. That's the only way to modify that one. Here we have wait. So 1 3 and 3 1. We have I'm missing something. We have 1 2 1, and then we have 2 1 1 in any order there. So that's 4 ways, and then here we have also 1 2 1's already duplicate, so we have 1 1 2. Okay, let's expand it to 5 first, and then we can figure it out from here. 1 4 4 1. We have let's do that. And let's make this a little bit more readable. Albeit not really more readable. Yeah. So we can do it like this. And we have 1 3 1. 1 1 3. And we have 1 through 1's already there, so we have 3 1 1. We have, I feel like I'm overcooking this. There are 7 ways to make this. 3 ways to make this. Wait, 8 ways to make this, 4 ways to make that. There's no way this just like straight doubles, right? Like this is surely not. On 1 3 3 1 1 2 1. So 1 1 2 1. And we have 1 2 1 1. Yeah. How is both of those actually? No, wait, no, there's one more. 2 1 1 1. Nothing else changes there. We have 1 1 1 1 1. 1 2 1, and then 1 1 1 2. Have this also has. Oh wait, I see. Okay, wait. This is starting to make a little bit more sense to me. Wait, so there's only one way to make 1, which is 1. There's only 2 ways to make 2. 1 1, and then 2. And then here we have and here we're also missing 2 2. Looks like. Yeah. 8 ways to make 4. No, this is not helpful. Wait. I know this is fine because then we can just. Okay, yeah, I see. So what is the easiest way to go about this? And here we also are including 1 2 2, 2 1 2. Oh, this kind of explodes a little, I think. 3 4 5 6 7 8 9 10 11 12 13 14. And then there's also 3 2. And there's also There's also 2, 3. We've already accounted for the 4s. Okay. Combinatorics. And 6 is interesting because we don't add 1 to the thing anymore. Let's assume. Yeah. So we can, let's take this out just to test in theory. Let's make this max points 4. Actually, it's a little bit annoying. Let's do 2. No. This problem's so annoying. This problem's annoying because I'm bad at math. Are there hints I could pull? No? Okay. Sliding window, really? I'm gonna make an inference here. Okay, let me reason about it in a different way. I think the previous numbers were fine. Yeah, I liked 3 and 5. So we have, just for one hand, there is possible, our possible hands 1, 2, 3, 4, 5. After 2 hands, there are possible 1, 2, 2, 2. Wait, no. So there are 5 hands here. This one has 2. Three. There are 5 ways to make this. Wait, no. Right? No, yes. Oh, wait, okay, wait. This is starting, I think this is starting to make sense again. 9 times 2, and then there's one way to make 10. 3. Wait, no, there's no way to make 10 because we already stopped at 5. Okay, wait, this is making sense. So there's so in here that also sets the ceiling on the number of hands that can be played here. Wait. Okay, wait, I think I get it. I think I get it now. Wait, I think I get it. Wait, guys, I get it. Wait, guys, I think I actually get it. Vector double. There are max points. Other way around. Okay, let's move this over here so I can actually read this. Is this readable? Yeah. Let's see if anyone's. Yeah. Okay. I think I get it now. I think I get it. And then we need 0 here. Actually, no. We need 1 here. And then this is the most number of hands are k possible hands. So now we fill in the initial state. Less than k. K is the number. Yeah, k. DP of 0 and zero and I equals 1, I think. I think that is how we initialize it. We can just assume that this is not 1 index, or we can assume that this is 1 index just to make it easier to reason about it. Yeah, okay, yeah, this makes sense. We can get rid of these braces even. Okay, now we get to the fun part. Um, where do we go from here? We could even just default initialize everything as 1. Honestly. I'll have to benchmark that after. So each of these, dp at I of, I know, for int j equals 0, j is less than k, j plus plus. Right? We should calculate all of these at least. Hmm. So for each of these, we want So I is the big loop. Make this more easy for me to understand mentally. dp at I of j we add this is where the extra layer comes in. K equals 0. K, oh wait, k equals 1. K is less than or equal to max points. K plus plus. If so these are each possible additional card that can be drawn right now. So then where do we go from here? We get j let's do the dp of I, and then something plus k, or something. We can't use k because there's already a k. Let's use kk. No. Card. Let's just use card here. No, we can't just do this. We have to do plus max points. I of j equals plus equals dp of I minus 1, and then what else? We want let's max points here. I minus 1 of k minus card. And then this is confusing. This is so confusing. I'm getting quite lost, low-key. We're so close. This is like... And if it's greater than... Yeah, if it's greater than, we can add. If j is... So if j is greater than k, then we can dp at ij, we can add dp at I j minus 1, or I minus 1 of j. We need one more if here. K minus card is less than 0, then we break this inner loop. And then we accumulate here. And then finally, at the end, we do the math. Double as equals 0. Numerator denom equals 0 for int I in 0 I. Let's just make this a little bit easier, actually. Actually, no. Let's not make this easier. Good job, me. Int cur equals 1. For each I in max point, dp.back if cur is less than equal to n, numerator, we add I to that. Denom always gets it though. Then we return num divided by denom. See if this works. Uh-oh. That's not ideal. Let's make this a little bit more readable. Why is this breaking? That's not supposed to happen. Whoops. Again? Which test case is this? I-10? This is... Oh, duh. I see. Wait, what? Max points is 10. Oh. Okay. Right? That's not ideal. Let's make the, oh, wait. Line 26? Long. Why are these doubles again? Long. Okay, so it's always printing out 1, which is not what's supposed to happen. Okay, I've spent way too long on this problem. I think I just need to look at the answers here. Wow, wait, this is a crazy problem. Yeah, let me read through this. This is definitely one of the proofs of all time. I'm not enjoying reading this. I have less than n? Beginning else is 0 points. To write down the recurrence relation. With I points, Alice has to have drawn some number. That makes sense. Recurrence relation. find j points at that state. Okay, sure. This makes sense. It's like giga slow though, yeah. Oh, I see. That makes sense now. Okay. n+1? Oh, I see. I guess that makes sense. This is like, it's crazy. This makes so much sense. I was like 50% of the way there. I just did it in like the really dumb way. Let's get rid of the correct things. There we go. Okay, so just looking at this. Vector of double dp. So we need n+1 values because we care up to n. Yeah. Okay. So then we get 0 equals I. So then for int I equals 0, that's less than n+1, I plus plus. Okay. Okay, greater than 0. I don't understand this at all. I don't get this. I don't understand why. Wait, this is one. Wait, this, I don't get it. Wait, why is, I don't understand why the ternary thing is here. What does this represent? Let's see. So when k is 0, oh, I see. Let's just set it as 1 for now, and then we'll hit that issue when we get there. So it's that's such a mood. That's pretty funny, to be honest. This is the probability of all the states that we could have reached I from to divide by max points. Cause so what does the sum represent? Let's just pause it here. Because all the possible previous states could have reached it from. Or the sum of all of those. Oh, I see. Okay, yeah. Because from each of those, there's only one way to get to the current one. So we have to divide by the number of possible cards. So we set that to sum divided by max points. And then what else happens? So okay, now we shift the window. So if I is less than k, then we add it because because if we're at k or above, then we stop. So this controls the right end of the sliding window. So if I is less than k, then we add the current value, and then if I minus max points. So if this is in bounds, and yeah, okay. Max points is less than k. So this is just the bound of the window. Okay. And then accumulate. What does accumulate do? Oh, okay. We go from range starting at k, dp.end, and then default of 0. It was 1. And then it should error. I don't understand why, but I just like if k is 0, return 1. I can. Okay, sure. I mean, sure. This is quite a horrific problem, I can't lie. How are these 0 runtimes done? Is this no different than mine? If n is equal to... Oh, I see. So this is like the ceiling, return 1. Initialize it, double sum. It should be compiled away. Oh, and then they add the result there. Okay. That makes sense. And result add dp of I. And then we can do like one pass on this. Yeah, and then we don't care about preserving it from here. Okay, that makes sense. Res. Okay, well, sure, I guess. Okay. And just undo that. Does this even matter? Wow. Wow, what a problem. What else can we do with this? I feel like this shouldn't be this slow. What does this guy do? Yeah, okay. Oh, wait. We don't need that. Yeah, I can't lie. I don't have any idea what is happening. Actually, like, I have some idea, but it's, like, really hard to intuit. Hmm. Appreciate it, Janine. So each instance, sum is probability of previous values. I see. Okay. The way to understand initializing to 1 is that it'll always, every possible solution will include a 0. Okay. So the probability that it includes a 1 is 1 over that. Yeah, that makes sense. And then probability of that we get 2 is, oh, I see. Okay, yeah. Okay, this actually makes complete sense now. Okay, cool. Let's just get the same time. Unlucky. Yeah. This is, which problem is this? 837. New 21 game. Yeah, okay. Neat. That problem was definitely a doozy. Like, mostly because I just cannot reason about math in a reasonable way. I guess that just means I need to get better at it now. So, yeah. I can add this to my whatchamacallit, my Notion. Let me just make sure I don't dox myself again. Okay, this is safe. Yeah, okay. Let's add 837. New 21 game. It's still really funny to me that they call it 21 game because they can't say blackjack because that's gambling, I'm guessing. I think that's why, at least. Medium, but I feel like this should have been hard just because, like, I thought it was hard. That's definitely a skill issue, but what do you know? So this was dynamic programming and sliding window. But yeah, it's not gonna be more dynamic programming, and then sliding window is the optimization. It's a daily. Let's see, what do we? how do we describe this solution? dp of I is that a probability that a solution contains probability that a solution, I don't know, and will have value of some I at some point. Yeah, this problem reminded me of climbing stairs the more I looked at it. Sliding window for predecessors. Yeah, I think that's probably the best way for me to remember how I did this. Yeah, that was a doozy. All right, let's see. Where were we? Where are we on Kaleidoscope? I think I'll get this finished up, and I think I'll call it there for today at least. I think I've written quite a lot of code, good and bad code. Yeah. We can move this back here. All right, so we finished function codegen. And then this bug we'll figure out at some other point. For now, codegen doesn't get us much except that we can look at the IR calls. Yeah, that's cool. Yeah, okay. Finds an existing IR function. It's not validate signature. I don't get it though. Why is this a bug? My brain's a little fried. Let's ask chat. But don't have the... But if they're the same parameter types, same contract, then isn't it supposed to fail? Okay. Oh, okay, I see. That explains what the bug is. So the problem here is that um, this should work. This should work. And it should, I guess, override this. Is my understanding. The point of confusion for me was that they both have the same, I guess, contract with the lack of a more human, lack of a more human way to describe it. So this extern foo takes in a double, and this foo that takes in a b also takes in a double. So it should work. It should override the foo a, I believe. But it doesn't for some reason. So let's figure it out. This is a good exercise. Yeah. And let's see. What does this say? I'm thinking just adding an extra check here. Eh. F is not empty. Let's see what ChatGPT says I should do here. Ew, that is one way to do it, yeah. Okay, that actually makes sense now. Let's see, what do we have here? Oh, we have a lot of fun toys to play with. Do we add an extra check or override it? Okay. Okay, so this is fine. Um, wait. Wait, no. So we don't empty check. So replace empty check with arity check. Oh, I see. Okay, so we need this still. And then happens here. Also, again, my sister is playing piano. Everyone clap for her. This is mandatory if you are viewing. Okay, so this makes sense. Let's add the arity check. If okay, so if the arg size, so the number of arguments does not equal I don't have a getter for the I don't have a getter for the number of args. That's really annoying. Get args size turn LVM function, and it's the pointer log error v with function cannot be redefined with different number of args. And then while we're at it, let's add that. Let's add that getter real quick. Header. That's where we need. Function AST. Yeah. Here. Yeah. Wait, no, it's under prototype AST. And we need const vector of string get args. Now we go back here. And then prototype AST. And constant vector of stud string reference prototype AST get args return args. So now this should work properly. Where is this? It's not here, it's up here. These two lines. So this should check that properly now. And then what else do we need to add? We need to overwrite. We need to overwrite the arg names. And what do we do here? we iterate again, I guess. Ugh. Eee. You. Empty check stops multiple definitions. Arity check stops mismatch contracts. Okay, so now we need to rename all of the things, which is a little bit annoying, but that's fine. We can live with it. It's not the end of the world. Okay. I think this might actually be the only non-ugly way to go about this. Unless we can like do a zip or something. Arg iter. Arg begin. Arg. This is terrible. Has to be a better way to do this. Yeah, we can move the I outside, actually. Int unsigned dot I equals 0. Sign E equals proto get args. It might be easier to I hate this. Oh wait, we don't even need to define E, I think. Yeah, we can just ignore the giant train car collision for a second. This is fine. That's how it goes. We can arg iter set name. We can set to proto get args of I. Yeah. No problems here. No problems here, Chief. No ugly code being written. Let's do that. Let's do that for now. Let's fix the driver now. Yeah. So we'll add optimizations later. We'll do JIT compiler support later. For now, all we care about is printing out the stuff. we do something different now? Where does this live? So the codegen stuff. Initialize module. Handle. Okay, these handlers. Okay. And this is in the parser. This is down here. I lost where I was. Okay, let's center here. So then, case token end of file, we return. Semicolon, we skip here. Okay. If auto ast equals parse definition. And then we can add more stuff here. Auto IR equals st codegen. I have a nice little macro that in visual mode, instead of like, so J and K like move up and down. So capital J moves down and capital K moves up. What a nice macro to have. Anyways, now we need to add braces around this for clarity. Yeah. Parse function. And then this also means we need to do this gross stuff. Parse function, and then IR print to std error. Errors? Interesting. Oh yeah, I guess that makes sense. That is the LLVM error buffer. Okay, so let's try this again now here. And then here we do parse xturn instead. Xturn. And we copy this again. And top level expert. Top level expert. And then here, top level expert. Okay, so now this should work. Uh-oh. Where is this called? Under compiler. Right? Where does this come from? Oh, compiler. Yeah. Okay. Oh, it's a problem in LLVM. Oh, am I using the wrong? Did I just upgrade my C++? Oh, I probably need to use Clang, huh? Set C++ version cmake. Alright, set C plus compiler cmake. Okay. Let's put it in the make file. -d. Oh, we can just no, we put it up here, right? Uh, so we need cmake cxx compiler. This is Clang. Clang plus plus. We probably need to mess with this. Uh, hmm. Well, this is not ideal. Well, the good news is we know the error is not in the make file. Bad news is we know it's... The bad news is we know that it's in AST, which is arguably worse. What happens if I just delete that? Bad things happen. I'm just gonna plug this into ChatGPT. Oh, wait. Wait, I need to include module. Module. There we go. Okay, first try. Oh no. Oh no. Okay, we're gonna need to include a lot of things, it looks like. Okay, let's just give this all to the ChatGPT. There's so much stuff. Ah. Just dump the headers in each file. You know what? This I'm just gonna copy it over from the code reference and call it a day. This will just be easier. Yeah, let's see if this works. Uh-oh. Parser needs some of these. Anyways, let's be a terrorist here. Surely this is good enough. Surely. Oh, that's really annoying. Okay, what am I doing? Oh, okay. Let's stop messing around with this too much. Oh, wait, I just remembered. Wait, I need to... Forgot about this one. Forgot about this. Let's undo this header mess, actually. Yeah, let's undo this header mess. I think in here actually was necessary, but the rest of these I think we can be greedy with. Let's get rid of those. Let's make here. This would be very important for me to learn. Wait, we can make this prettier. Yeah, that's a good call. Let's do this. What do I need to include again? And what else do we need here? We need LD flags. Core. Let's make this readable. LD flags. LD flags. This should work now. Right? No. All right, let's give this all to ChatGPT again. Ah. So it wasn't LD flags. Wait, make queen? Make. What's the G flag? Okay. Makes sense. Foreign support. Wait, what is this better way to do this? Oh. Then we can just get rid of all this mess that I just added. Wait, that's so nice. Kaleidoscopes, theme extender. Let's Let's see. What do I add to this? Okay. We add these. We add those. Wait, what? Wait, what changed? Oh, I see. Okay, sure. I'm gonna add those for now, at least. I feel like I'm gonna need them later. Yeah, we're just gonna vibe code the CMake files. I really don't want to look at this too closely. I'm on Arch. Wait. I just copied and then immediately copied straight into there. Yummy. Just straight text. One second. What? What is happening? What? Yes. Yes, I would like that. I would very much like that. Let's just vibe code this. Wi-Fi dropped for a second. Whoops. Stream still up? I hope stream's still up. Let's refresh. Okay, we're still streaming. Looks like. Yeah. Okay. Neat. So we're still vibe cmakelists. We're just gonna keep pasting this into ChatGPT until it does something. Oh. You know what? Let's just keep going. This is very high quality code we're writing here. Incredibly high quality. Okay, let's undo all of this mess. Still same error. Let's try this again. Oh wait, it actually worked? Wait. Wait, it worked. Wait, actually vibe coded something. Sure. Uh-oh. That's not ideal. Oh, wait, I actually need to make the thing, right? Huh. Let's add everything. Let's see. Where are we now? So this goes in AST. Does this make it anywhere here? I see. That's what they do. Do we need initialize module? Okay, that's what's missing. Okay. Yeah, let's go back to compiler. This lives here. IR? I don't know. Dump IR. We're gonna call it that. We're gonna do yeah, let's start with that at least. Dump IR. And then underneath the run loop, void parser, dump IR. ST. Hey, we can put this in the constructor actually, huh? Wait, we need to do this differently. We need AST context. We'll just to do AST context stuff. AST module. Yeah, this will be next time's task, I fear. Yeah. Yeah. Okay. Yeah. So I think that's where I'm gonna call it today. This has been how long of a stream? Started 3:30, so 4, 5, 6, 7, close to 4 hours roughly. Yeah. If you're still here, or if you're watching the VOD after the stream ended, make sure you like the VOD and sub to my channel. I'll schedule. There's a good chance that tomorrow's stream is already scheduled. By the time the VOD is up, so make sure you um click the thing that lets you get notified. Um, it'll probably be at a more irregular time because I'm quite booked tomorrow. It turns out, so it might be quite late, but we'll see what happens. Yeah, if you know anyone that can refer me anywhere, please send them my resume. um, yeah, next time I'll hopefully be able to finish putting all the pieces together in this code gen sort of step. So, yep. Take care, y'all. Take it easy.